Hey everyone, and welcome back to the 10th tutorial in the C Programming with Windows API series. In the previous tutorial, we covered the concept of namespaces and how we can use namespaces to organize different functions or variables and data types across our application. In this tutorial, we're going to be covering a topic which we've already previously discussed called pointers. Except in this case, we're going to cover an advanced aspect of pointers via dereferencing or indexing them, and type conversions with pointers. So let's go ahead and open up our Visual Studio's IDE. Here I have it open. I have a file called tutorial10.cpp created with the template that we used from the previous tutorial and a namespace called tools, which contains the function wait. And wait is defined or referenced right here and called right here. Okay, so I'm just going to go ahead and zoom in right here for you. So let's just begin by defining a simple char pointer called A and setting it equal to I love to code, for example. Okay, so here I have a char pointer called A equal to I love to code. So we know now what a pointer is, and we know how to define a pointer. But how do we manipulate a pointer? And what do I mean by manipulate is, how do we, for example, this is a const char of 16 bytes. Let's say I want to output this string here. So I do printf s n a, okay? And then I run the application. So this simply outputs I love to code. But let's assume that I wanted to output the same variable, right? But the string from here. So like, I don't want to output this part, I want to simply output this part, okay? So this part right here of the string, we can actually count as 1, 2, or rather, 1, 2, 3, 4, 5, 6, 7. This character right here comes after the 7th character in the char array, or rather, sorry, the char pointer. So if I wanted to output the 7th character and on from the char pointer, what I can do is I can increment the char pointer from its original position, which is starting from 0, plus 7 bytes. So if I implemented plus 7 bytes, now I will output the string, and all the characters after this character here, this one right here, will be outputted. So I'm going to go ahead and run the application. And as you can see, the output is produced as simply to code. So what I just did here is I indexed a pointer. Okay? So I simply took the pointer A, which starts from index 0, and I incremented 7 bytes to that pointer. Now, let's actually create a little fun function which we're going to use to output a random amount of bytes for this pointer every time. So let me show you what I mean. For now, I'm going to create a function with an int data type and just call it like generate random position, or random pos for short. Okay, and it's going to take a parameter char input, pointer input. Okay, so I'm going to actually place this function inside of the tools namespace, just so that we can actually integrate the namespace which we used from the previous tutorial in this one. So I'm going to make the generate random pos function as part of the tools namespace by putting tools : so that whenever I call it, I can call it from this specific namespace. So I'm going to use now an API known as getTickCount. And the reason I'm going to be using getTickCount is because I want to be able to get a random position inside of this specific string every time, but a random one every time. How I'm going to do this is I'm going to explain to you in a second. So let me just pull up something useful. A useful tool I like to use called MSDN, which stands for the Microsoft Development Network. And basically what this is provided by Microsoft. They give us a documentation of every single, literally every single, or to some extent, they give us a documentation of some of the Windows API functions. They don't give us a documentation of some functions known as undocumented functions, which are functions that are used specifically inside the system. However, they give us a documentation of most of, or like 70 to 80% of every function inside of the Windows API. Okay, so I'm going to pull it up right here from my second monitor. And here we have the getTickCount function. So what this function does basically is it returns the number of milliseconds that have elapsed since the system was started. And basically it just returns something called a dword, and a dword is basically just an unsigned long data type. It's just a fancy way for Microsoft to like kind of define variables inside of much more like a shorter, more commonly used name. So if we hover over dword here, let me just call it dword something. If I hover over dword, it says typedef unsigned long dword. And all the typedef actually is actually like a syntax, which I haven't actually talked about yet, but might as well just do it now. So typedef is basically a syntax which allows me to declare a specific object to another object. So what I mean by this is like, for example, like we have here in the dword, they have like an unsigned long data type. So the first the first part of syntax, the first parameter you could say that syntax is passed to typedef is the name or object that you want to like cast to something else. So like here they have unsigned long, and then you call it whatever you want. So here I have dword. So in this case, whenever I call the dword name, it assumes that I'm talking about unsigned long. There are other ways to use typedef, but we're going to be talking about those later on. For now, I'm just showing you why a dword is a shorter form for unsigned long. Okay, so let me go back here to the Microsoft MSDN reference page for the getTickCount API. So basically, it just returns the number of seconds, or milliseconds rather, since the system has started. And why am I going to be using this to generate random numbers? Well, the reason being is because the amount of milliseconds that this function returns will always get incremented, like for any amount of time that the computer is running, up to 49.7 days. But that's a lot of milliseconds. So anyways, I'm going to use this API right here. And actually, sorry, let me bring this back up here. MSDN also explains how this API is used, how it's declared, how it's defined rather, which parameters it takes, which in this case it takes no parameters because it's just the argument is just void, which as we know is nothing. And it tells us what it returns. So the return value is the number of milliseconds, right? Cool. So as we know, there's 1,000 milliseconds in a second, right? So every time we call the function, and then we call it again, it's going to basically calculate how many milliseconds have elapsed since we called that function. So let me go ahead and use that. So I'm going to define an integer data type called increment, okay? And basically all the increment data type is going to be responsible for us is incrementing a certain amount of characters inside the input char data type. Okay, so I'm going to set increment equal to getTickCount, which is a dword as we know. And, right, so the parameter. And I'm going to do something called bitAnd, which is basically going to get the, how do I say this? Well, it's going to get the hexadecimal, like, hexadecimal decimal representation, in this case, since we're talking about an integer data type, of whatever the length of input is. So what I mean by this is getTickCount is going to be like a random number every time, like a random number of milliseconds, right? And the bitAnd, we're going to do something called, this is the bitAnd, right? The normal ampersand is known as bitAnd. So when we're dealing with two mathematical operations, this bitAnd is used as like an operator. However, when we're using it as like in front of like a variable, like for example, here. So if I use it like in front of the variable a, it's known as dereferencing. But when I'm using it with two numbers, it's used as a math operator. So that's how it works. And then I'm going to use something called L string a. And basically, remember in like the last tutorial where we talked about L string cat a, which allowed us to append one string, so string 2 to string 1. Well, this L string length a also comes from the windows.h header file, and basically it's a Windows API. And actually, let me go ahead here on my screen and pull up the documentation for this L string length a API, so you guys can actually see what it means. So L string length, as you can see, and this is the MSDN page again, determines the length of the specified string, not including the null terminator character. Okay, so remember, the null character, which is the null terminator at the end. So, as you can see here, L string length a is an integer data type called L string length, and it takes in, so in is basically, this in is a macro, and a macro is like, so this is like a macro. So this is the in definition right here, in. Or rather, they use, I think, just one underscore, right? So this is how in is defined. So basically, all it is like it's saying that the input. So it's kind of like a naming convention used to define that this string or this parameter right here will be used as input for this function. So I mean, I can even prove it to you. If I copy and paste the function declaration right here into like right here, for example, we can see, and if we hover over in, oops, let me just 1 second. Okay, so if we hover over in here, it actually has a really long definition, but the bottom line for this definition here is that this in parameter or this in macro, all it's telling us is this. Whatever this variable will be, it's only coming into the function. There's also another one called out. Oops, I spelled out wrong. Fail. So there's another one called out, another macro, which also has like a similar definition. But all it means is whatever variable is declared after this is coming out from the function. So there's like functions that take parameters in, like we're doing right here, and like there's also like if we, for example, cast another parameter called out, we can also like return this parameter, assuming that like this is a char pointer, for example, right? We can also return this parameter from the function. Okay, so that would be like an out parameter, but this here we only have in. So anyways, go back to here and the normal definition to remove the red underline like that. Okay, so basically this L string length, which we're going to be using, just returns the length of the string of basically whatever string of text that we input into the parameter. So in this case, we're just putting input here. Okay, so this get tick count is going to use a random number seed, basically the random number being the milliseconds since the system has started, bit and the length of the input, which is always going to be the same. However, this number is not going to be the same. But this is our static number. This ensures that basically putting a bit and of the L string length of the input parameter ensures that this increment value will never be bigger than the length of the string. So in this case, since we're using it as like an index for incrementation, it's just going to ensure that we're never going to get like a blank here. We're never going to have like a blank outputted as the incrementation number. This value is never going to be greater than the length of the string. So anyways, I'm just going to return the input plus, as we did before with incrementation, the increment variable. So, sorry, I'm just going to define this as a char. And the reason it's giving me that red underline is basically it's saying that the definition that we've defined here is not the same as the declaration for the function type here. So I'm just going to change this to a char pointer. Oops. There we go, like that. And there. Okay, so I just returned the incrementation. So basically, if I print A right now, right, and run the application, every time we run it, it's going to output like a different type of string. So, oops, sorry. I'm so clumsy. I need to do the call the function here. Pass a to the parameter of that function, and then just run it again. So as you can see in this scenario, it outputted just code with the space before it. So the random number that was generated here from this instance was 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, so basically it just outputted a plus 9 in this scenario. So let's just run this over a couple times, and I'm actually just going to make this easier for us and just call it inside a for loop like we talked about previously. So I'm going to set the initial variable of the for loop I equal to 0 and just set it like I less than 10 and then plus plus I. And to ensure that this get tick count kind of like generates a random number further from the last like generation, so like basically to ensure that this random number will never be somewhere more or less the same, I'm just going to call another Windows API, and let me actually pull it up here for you guys 1 second. I'll just go to the first monitor and just call oops. So the API that I'm going to be using now is called Sleep, and basically all this Windows API does is it basically stops the execution of the program for an X period amount of time. So as you can see, the input parameter for this is another D word. So basically it's just the number of milliseconds that you want to sleep for. Basically we can stop execution for a certain period of time inside the program. So wherever I put it, for example, and this is another Windows API, I can just call, like, for example, I'm going to sleep 100 milliseconds every time. So every time it hits this point of the code, 100 milliseconds will be counted before this loop goes over again and again and again. And in that case, the get tick count will obviously be incremented by 100 milliseconds plus however many milliseconds it took for it to get to like this part in the code every time it executes. So if I run it, you can see that a random number was generated every time, and the output is always random. So as you can see here, it's E question mark, ode question mark, whatever, whatever, whatever. And as you can see, this is basically how we can use incrementation to reference a specific value from within a pointer. Pretty cool? Okay. So now let me actually show you something else, something cool called breakpoints, which are used at the debugger level. And what breakpoints allow us to do is they allow us, which this kind of actually moves into two tutorials ahead, but I'm going to show you guys something really cool. It's going to allow us to see the number here, which is actually being generated like when it gets compiled, or rather when it's getting compiled. So this is a unique feature of that Visual Studio provides for us called debugging, which allows us to set a breakpoint, which is kind of like a point of where the execution stops, and allows us to debug every single parameter that was inputted in that local function up to that point. So what I mean by this is right here we have a little panel on the side of our file. Like every file has like a little panel on the side, and this allows us to set a breakpoint at a specific line. So for example, if I wanted to set a breakpoint at line 7, I can click here just on line 7 on this side panel here, click it, and it sets this little red circle here. So that means whenever I run the application in debug mode, where it links the PDB, the program database, I'll talk about that later on, it'll stop the execution of the program at this point. So I can actually, before this function, or rather this function, before this data type gets defined, I can check the value of get tick count, and I can also check the value of L string length A. And I can do this by doing something called adding a watch, which basically allows us to watch that specific variable definition and kind of see how the value changes over time. So I'm actually going to, what I'm going to do is I'm going to set a breakpoint on this specific line here, and I'm going to set a breakpoint at this line. So what this is going to do is when I run this application, it's going to stop at when it hits this line. So every time the for loop goes on, and it hits this line in this function, whenever it's called here, it's going to stop, and I'm going to be able to see the values of whatever is inside here or here. And how I'm going to do this is I'm going to add a watch to it. So I'm going to do that when we start execution. So I'm going to run the application. You'll see what I mean. Notice how here, after I ran the application, we see a little arrow here inside the little red circle, and this means that the breakpoint was triggered. and it stopped execution at this point here. So what I'm gonna do is I'm gonna add a watch to this specific like operation here. I can do this by right-clicking on it, or rather highlighting what I want to look for. So in this case, it's input plus increment, and I'm going to add a watch to it. I'm also going to add a watch to the increment variable. Oops, add watch. And this is a watch. Oops, okay. So as we can see here, right now, at this part in the execution, the input plus increment isn't it returns error reading characters of string. Basically, that's saying that like it's not actually called yet inside memory, so we can't get like the value. The debugger can't get the value of it yet. And here, increment is returned to this long string here, negative something something. And the reason being is because increment wasn't even actually defined yet. Because it hit the breakpoint on this line, it stops the execution here before increment even gets assigned, which is pretty cool, huh? Okay, so I'm going to click continue here, right here. So it's going to go on to the next breakpoint. And now we're at this part in the execution. So now increment was assigned, and we also know the value of input, which is this string here. So this this operation can return true because like we know all the variables are set already. And we can see here that increment, the number integer increment, was the number 9. And the input plus increment outputs code, or there's actually a space here beside the code. And we can actually do something kind of cool. We can right click on this input plus increment like line here in the watch, and we can click hexadecimal display. Oops. Here it gives us like a hexadecimal value of where this code appears in memory. So where this specific string appears in memory during execution, we can right-click on it and click copy value. I'm just going to paste it right here. All we need is this hexadecimal string here, or rather that hexadecimal address right there. We can go to debug, the debug tab at the top, go to Windows, the Windows option, and it's a drop-down, another one. Go to memory, and go to memory 1. Now I'm going to put this right here, actually, so we can kind of see it more clearly. This right here is so at execution time of this program, or at debug level, it shows us the memory address of all code that's going down here. So all code, this is actually the memory within this code, okay? So right here where it says address, I'm going to go ahead and right-click and click paste. This replaces the address with the one that I just copied from the watch. Oops, let me just close these. And this one. And okay, so let me go ahead and go back, and watch. Oops. Right, so I had it here. So right here, I'm going to copy this value, copy it here. All I need is this one here. Copy that, go back to the memory tab, and output it here. So as we can see, I just copied this memory address from the watch, which is this one right here, into the memory address input box. And now we can see from the beginning. So this is actually the exact location where this specific memory is being displayed for this instance. So in our case right here, these are the bytes right here. Sorry. These are the bytes for this specific operation. So as you can see, the output is 2 code. There's actually a space right here, and then 2 code up until this point here. Up until the first consecutive number of periods, okay? So this is another point in our program. This is another point of execution. These are actually coming from the PDB, which is the program database. At compile time. These are just like error codes, or rather error strings. So these strings are irrelevant, but all we're looking at right here, all that's important is this 2 code string, which is the return operation from this operation. Okay, so we can actually prove that. As we can see, the increment right here. Oops, let me go back to check off. I'm going to untick hexadecimal display, and I can see the number 6 right here. Okay, so if I count right here inside the string, 1, 2, 3, 4, 5, 6, you see that we're stopped at this point in the string, and this is the string that's left inside this pointer. So actually, input plus 6 is in fact, we're checking right now ourselves that it's in fact correct, because this is the string that we would see from input, or rather, a plus 6. Okay, cool. So I'm actually just going to stop the execution right now and remove these breakpoints here, and I'm going to move over to release mode. So now I want to be talking about the actual indexing. So this was just that we talked about indexing. Now I'm going to be talking about dereferencing the pointer. So what we just did is we specifically indexed a number or incremented a number directly to the pointer. Now I'm going to do something called dereferencing the pointer. So what this means is this is sort of similar to indexing. However, okay, so remember when we talked about pointers and I said that a pointer starts from any random part or any random point in memory? Well, for example, this right here is a random memory region. As we saw in the memory, when we pulled up the memory window right here on the side, we had all those different addresses. This I love to code string was at a random point in that memory. Okay, so right now we're going to tell you about dereferencing and dereferencing a pointer to a specific index in memory. So here, let me just show you rather than talking. I'm going to remove this function now, and I'm going to also remove it from the namespace because we're not going to be using it anymore. I'm just going to close the tools window, tools.h. And right now I'm going to dereference the string of char a, char pointer a. Okay, so basically I can type this little ampersand here, which is going to allow me to dereference a string, because remember when we talked about pointers and I spoke about dereferencing an integer to assign it to a pointer, because you can't assign an integer to an integer pointer? Well, now we're going to be dereferencing a string, a pointer, a char pointer, sorry. So I'm going to dereference a by typing the ampersand a, and now this sets a to a specific region in memory at the beginning of wherever a begins. In this case, it's I. So I can actually output now a as an array. Rather, if I were to just do a0 like so, if I ran it, we triggered a breakpoint because right now we're not specifically outputting the first. Right now, what my goal is, what I'm about to show you, is how to output the very first index of A. So if I just wrote A0 and tried to output the first character, I can't do that. I can't output the first character of a char pointer. However, I can output the whole string of a char pointer and kind of go from there. But how I do that is I have to set A to a specific memory region so that we can start specifically from that point in A. So I'm going to do that by typing an ampersand and A0. So now A is set to I love to code, but as a dereference string. So if I were to run that again, it would output I love to code as the string. So now this 0 specifically starts from wherever this point is in the string, which in this case it's this whole string. So if I were to write A2, for example, all it would output is love to code with no space at the beginning. So I'm going to run this just to show you. So as you can see in the command prompt, the output is love to code. Okay, I'm going to stop execution. So that's really all I wanted to show you about dereferencing a string, because basically all we're doing is we're setting this A pointer directly to a specific point in memory. You can't look at this like indexing. It's sort of like indexing because it achieves the same overall goal. However, in this case, we're setting A to a specific memory region. We're not just setting A as a bland memory region wherever it is, like in general, wherever it is located. We're setting it to a specific memory region, wherever it begins. So in this case, it's 0, A0. Okay, cool. So now I want to talk a little bit about type conversions. And actually, I'm going to show you an example I'm going to show you an example with that API that we used called getTickCount. And I'm going to show you the difference between valid type conversions and invalid type conversions. So let me just go ahead and call that getTickCount function again right here. All I want to do is I want to highlight it for you so you can see kind of how it's defined. So as you can see, it's a dword. And dword, as we know, it's a type def for the data type unsigned long, which is just stores like a long. It's basically more integers that can be stored than a normal integer data type. That's all you really need to know from it. And it requires no parameters. So I'm going to actually set a dword variable, which is just looking, you can just look at it like unsigned long. And by the way, hold on, let me first set it. So let's just say tick count. Okay, so that's all I'm going to set the variable name to. By the way, there's other different kinds of type defs that Microsoft provides for us inside the Windows.h header file, such are char. And basically, you can look at it as a more, sorry, I forgot a semicolon here. You can look at it as a more unique way of writing like a standard like data type, and also a shorter. You can use it as like a shorter acronym for writing a data type. For example, like dword is shorter for unsigned long, or rather, there's also like we also have like unsigned short, right? But Microsoft provides the type def for us ushort, which also ushort, which is short for unsigned short, as you can see here. And like there's also like uchar, which is unsigned char, right? And there's also ones like word, which is unsigned short, which is like basically, as you know, okay, so ushort is also like a type for unsigned short, and word is also for unsigned short. And the reason they have two type defs for this is because in context, when ushort is used, it's used in a different they're used for different operations in context than like when a word is used. Even though they mean the same data type, they're used in a different context. And that's why they had two definitions or two type definitions for those data types. So anyways, let's move on. So all I want to show you here is I'm going to output right now the LU. So basically %LU is how you output. It's basically the identifier, the string identifier for a dword or unsigned long. So if I do LU tick count, it's going to output this string as a dword, a 32-bit string, up to 8 characters. So here it's 7 characters, but this dword can actually go up to 8 characters, assuming it's a 32-bit string. And by 32-bit string, I mean as long as it's like an unsigned long and not an unsigned long, which is a 64-bit data type, or 64-bit string when outputted as a string identifier, rather. So I'll go back here and right. So here we can see the output of a tick count is 5937257. Cool. So basically now I can also cast this as, for example, like an integer. And I'm going to explain in just a second. Let me just run it first for you. So casting this as an integer also works, and basically all this is I'm okay, hold on, let me actually change this to a D instead of LU and do that again just for you. So as you can see here, basically what I'm doing here is, even though this is an unsigned long even though this is an unsigned long value, I can still convert it to an integer, because remember how I talked about like integer and char being like the main data types of all programming? Like every other variable or every other kind of data type would revolve around an int and a char, and you can kind of work with conversions using int and chars. And the reason that I'm talking about conversions and the reason they're important is because, for example, here, I'm going to give you an instance after I explain this, but basically a valid conversion from a dword would also be converted into an integer. And what this allows us to do is something like this. Like let's say we're defining an int type def. Again, I'm using the type def value for an int, a, and I'm setting it equal to tick count, okay? So here, as you can see, when I set a equal to tick count, I can do a direct conversion. In this case, even though tick count is defined as a dword, which is an unsigned long, and int a is an an integer data type, I can still assign a directly to tick count. Basically, it's doing a type conversion, even though a is an integer and this is a dword. It's basically converting tick count by putting like in parameters in brackets the int in front of it. Whatever operator or whatever data type this is putting this in front of it, assuming that it's not the same data type as the a integer. And basically, that's all it is. That's all typecasting or type conversion is. Like, it allows us to convert a specific, like, let's say we have, okay, so let's say we are dealing with memory, okay? And we have, like, a void. I never actually talked about this, but let's say we have something called void pointer, and we have a void pointer A, okay? And then we have, this memory is set to, like, whatever, okay? And we want to assign, like, char A. Sorry, let me just stop execution. We want to assign char A, or rather char B, sorry, equal to A. Okay, so what a void pointer is, basically, I remember how I said void can't be actually used as a data type on its own. However, a void pointer can be used as a data type, and what it's commonly used for, and by the way, the type definition for this would be this, pvoid, or there's also lpvoid, which is basically the same thing. Basically, what it's used is it's used to store context of a string inside memory. Basically, it's a little complicated. A char data type isn't normally used to store context in memory. So, for example, if we're storing context in like remote locations across our application, we won't be using a char data type. However, we can use an unsigned char data type, for example. Uchar. Also, another way of saying uchar is byte. Okay, and this is more commonly used to like manipulate memory. So we're not actually talking about memory manipulation just yet. We'll talk about that more when we get into our intermediate tutorials. But for example, I'm just giving an example here. If I wanted to convert this void pointer to like an unsigned char pointer, I can do that simply by typecasting or type conversion. Just by simply typing this byte pointer in front of the A, it's going to allow me to convert all of these strings, all of these characters in memory into a byte pointer. And in fact, it is going to be valid. So as you can see here, whereas here, it's invalid. As you can see, there's a little underline under it. It says a value of type pvoid cannot be used to initialize a type of byte. And the thing is, if I want to manipulate byte as like a pointer, because manipulating void as a pointer is a little difficult because there are some downsides to it, which again I will talk about later on. But if I want to manipulate byte as a pointer, I can do that directly by just typecasting the A void pointer as a byte. Okay, and then I can just do like B, and then output B. So, yeah, there we go. And basically, the only reason... sorry. Oops. And there we have the string FDSGS outputted here. I was just like, for a second there, I forgot to convert the... or rather, change the D identifier to an S to output a string. Okay, cool. So that actually basically wraps up everything that I wanted to talk about for this tutorial, where we covered the debugger, how to use breakpoints, how to add a watch to a specific operation or operator. We talked about the ampersand operator and how to use it to like either the difference between dereferencing it and using it between two operators or two values in a mathematical equation. And we talked about type conversions, as well as indexing and incrementing a pointer. So that wraps up tutorial number 10. Now in the next tutorial, tutorial 11, we'll talk about memory management, allocation, manipulation, and the difference between dynamic and static memory. So thank you guys for watching. If you have any questions, feel free to leave a comment down below. If you enjoyed the video or liked it, please leave a thumbs up, and see ya.